In this video, I'm going to be going over how to solve whether an electrochemical cell will be spontaneous or not using something called a reduction potential value. So reduction potentials are denoted with Ered. A reduction potential tells us how much a species wants to become reduced or gain electrons. So what we can do is look at a species like silver and see the reduction potential value for it. So silver plus 1 electron, note this is reduction, will proceed to make Ag. This reaction will give us a reduction potential value of 0.80 volts. So as we can see, reduction potentials tell us the voltage associated with a species becoming reduced. We should note that higher Ered values mean a species wants to become reduced more. So if we were to see a species with a reduction potential value higher than 0.80 volts, we would say that that species wants to become reduced more than silver does. So how can we use this to solve for the E cell of a reaction and tell us whether an electrochemical cell is going to proceed spontaneously or not? Well, what we can do is say that the overall E cell is equal to the reduction potential of our cathode minus the reduction potential of our anode. So if we are met with a reaction like zinc plus copper 2 plus goes to zinc 2 plus copper, how can we decide whether this reaction is going to proceed spontaneously or not? Well, the first thing that we should do is decide the oxidation states of each species to decide whether which thing gets oxidized and which thing gets reduced. So zinc starts with an oxidation state of 0. On the right side of this reaction, it goes to +2. Copper 2 plus starts with an oxidation state of 2 plus, and it ends with an oxidation state of 0. So zinc started with an oxidation state of 0 and finished with an oxidation state of 2 plus. That means it was oxidized because it lost 2 electrons. We can call this our anode because we saw oxidation occur. Now, what about copper? Well, copper went from 2 plus to 0. This means it got reduced and gained 2 electrons. This can mean this was our cathode. So now we need to decide if we set up an electrochemical cell with zinc at our anode and copper at our cathode, would this electrochemical cell run spontaneously or not? So let's say E cell is equal to the reduction potential of our cathode minus the reduction potential of our anode, and fill in our values. So we need to decide which species is at our cathode and our anode before we set up this formula. We decided that copper is our cathode. Be careful because these are both reduction potential values, and we know that our anode is going to get oxidized. So because this is a subtraction type equation, we need to make sure we have our cathode and our anode in the correct places. So our cathode, which is copper, if we look at this table of reduction potential values, has an Ered value of 0.342 volts. So let's plug that in for our reduction potential of our cathode. So E cell is going to equal 0.342 volts minus the reduction potential of our anode, which is negative 0.76 volts. As we can see from this Ecell equation, we are going to get a positive value for Ecell. This means that if we were to set up an electrochemical cell with zinc at our anode and copper at our cathode, this redox reaction would occur spontaneously because our Ecell is greater than 0. So again, reduction potential tells you how likely a species is going to get reduced, and we can use the reduction potential of our cathode minus the reduction potential, I should say, of our anode to solve for our overall Ecell. And if that Ecell comes out to be positive, it is spontaneous. If that Ecell value is negative, that means that if we were to set up that electrochemical cell with that species at our anode and that species at our cathode, it would not run spontaneously, and we should not set that electrochemical cell up.